Alright, it's been a little while since we've done a video. So let's see if we can get back in the groove. So we're going to start on page 14, indefinite integrals. We already talked about the net change theorem. So an indefinite, and I've kind of already introduced indefinite integrals also. Just mentioned it briefly a couple days ago. Whoa! So an indefinite integral is an integral with no endpoints. So there's no lower and upper. There's no a and b. Huge important concept. What do we need to remember when our integral is indefinite? Oh, what are we maybe going to forget? Hopefully you guys are going to be blurting out plus c, right? When we need to add the constant. So for example, the integral of x to the third, x squared, excuse me, is 1/3 x to the third plus c, because the derivative of that is equal to x squared, right? So it's forwards and backwards. Okay, a definite integral, meaning it has endpoints. We always get a number out. A definite integral is a number. An indefinite integral is a family of functions. We say family of functions because the c can be anything. So the graphs would all look the same except that plus c would either shift it up or down. So let's just do a couple examples. We're not going to do all of these. So take a second, look at example 1a, and hopefully you're thinking of something that I have tried to beat into your brains. Algebra first, right? So you're going to distribute and then just anti-differentiate, and don't forget your plus c. We're not going to do that one. Let's do one with trig. Make it a little more interesting. So let's do b. So take a second and see if you can figure out what needs to happen on b. So hopefully you notice that the numerator is a double angle formula. So I can change it using that formula. If you don't know that formula, I don't know what to say. You need to learn it. And then we can cancel, right? And we have a property from many days ago that says we can pull a constant out. And then all we need to do is anti-differentiate cosine, and the integral or the antiderivative of cosine is sine, because the derivative of sine is cosine. And then don't forget your plus c. Okay. So just to show the difference between a definite and an indefinite, I've got some definite integrals in example 2. So again, I'm hoping that you gut instinct, you know what to do, because we've done it so many times. You're just going to FOIL it and then find the antiderivative and then plug in, like we had been doing. So let's look at the b again. Practice with some trig. And we're going to get some more practice on this kind of stuff sometime next week. I don't remember what day it is. I'm going to run out of space. Okay, squeezed it in. All right, so I want you to please pause the video, and I want you guys to take a minute and do this. Hopefully you can do this. So I'm hoping that what you did was notice that you could factor out a sine theta on top. You thought you were going to be done with those trig identities, didn't you? Haha. Not so much. I hate to rub it in, but... And then you've got a Pythagorean identity, 1 plus tangent squared. So I'm hoping you guys got this on your own. 1 plus tangent squared is equal to secant squared. And then it works out nicely. I mean, think about it. Integrating that would be gnarly, wouldn't it? Excuse me. So now all I have to do is integrate sine, and it's so much easier. So simplify first, then do the calculus, and your life becomes a million times easier. So the integral of sine, remember, is negative cosine. because the derivative of cosine is negative sine, and since this is positive, I need the negative in front. And then remember, we still have to evaluate this because it has endpoints. The previous one didn't have any endpoints, so we were done once we did the antiderivative. So we need to plug in the pi over 3 and the 0. And we don't need the plus c because remember when we do this subtraction, the plus c is going to cancel out. So like I mentioned before, if you're afraid you're going to forget the plus c when you need it, then do the plus c every time. Okay, not a big deal. So negative cosine of pi over 3 minus negative, right? Cosine of 0, oops, that's a 0, sorry. And what's cosine of pi over 3? 1/2? And cosine of 0 is 1, so the answer is 1/2. Okay, so let's flip to page 19. Give you a second to do that. We're going to use these indefinite integrals on page 19. So we've used U substitution to help us factor complicated equations that are quadratic in form. So maybe in algebra 1 or 2 you changed the form of these. So I don't want to do both of them because I don't want this video to be ridiculously long, but let's look at this. I hope you can recognize that this is quadratic in form, meaning this term has something from this term being squared, right? So when we use U substitution for this, we know we want this to be like a u squared and this to be a u. So we would say our u is t to the negative 1. We want that to be our u. And then we need to check, is u squared, so let's square both sides. What's t to the negative 1 squared? We talked about this the other day also, algebra 1, right? Power to a power we multiply, and that, lo and behold, ends up being that. So we were correct in the assumption that this was quadratic in form. So I'm going to substitute u squared right here, and I'm going to substitute u for the t to the negative 1 right there, and there's a negative 7 in front of that, and then a plus 12 and it equals 0, and now I can see this is quadratic and I can easily factor it and solve for u. And then I always like to say I don't care about u, I need to solve for t, right? The equation originally wanted me to solve for t. So I would substitute back in this u equals t to the negative 1, and then I would solve those. And since that's review, I'm not going to spend more time on that. We're going to use that, though, in integration problems. So we're taking baby steps. Excuse me. First, they're going to tell you what the u should be. So let's do this problem. They're telling me that u should be x to the third plus 5. So this whole quantity is going to be x to the third. The x to the third plus 5 is going to become the u. So this is going to go in here. But we can't have two variables, right? We need to figure out how to get rid of the x squared and the dx. So this is what we need to do. If u is x to the third plus 5, then the derivative of u would be 3x squared, right? Oh, look, it just happens to match up. How nice is that? Now, we also need to get rid of the dx, though. We don't want to integrate with respect to x. We want to integrate with respect to u. So here's what we do. We just multiply both sides by dx. Multiply this by dx, it cancels. Multiply this by dx. So now I can take, sorry guys, we can take this and it becomes just a du. This whole thing becomes du. So we have an integral, right? We have something to the 9th, and that something is u. Haha, that sounded funny. And then all of this stuff right here, 3x squared dx, is your du. Whoops, let me do that in the other color, sorry. Is your du, and now we can easily integrate that, right? So what's the integral of u to the 9th? Raise the power, divide by that power. Don't forget your plus c. And it, just like I said before, I don't care about u. The problem was an x. That sounded funny too, didn't it? So I need to substitute this back in. So 1 over 10 to the 10th, but instead of the u, I want the x to the third plus 5. So that is the antiderivative of this. That's the answer. Okay? Sheesh kebab. Okay. Let's do example 2. So the question is now, they're not giving us what u should be. So notice that the u was the thing inside of a function. So this is, we'll talk more about this when I'm here tomorrow. This is undoing chain rule, okay? So this is the, well, we'll talk more about that when I'm here tomorrow. So basically, when we're picking our u, it needs to be a function inside of another function. So I think this one is a little more obvious because it's very similar to the last one. Our u is 2 minus x because 2 minus x is inside of something being raised to the 6th power. So our next step is to find the derivative, and the derivative of that is -1. And then remember, we want to get rid of the dx, so we multiply both sides by dx. Now, honestly, when I'm doing these, I skip this step. I know I can go from here to here, right? Straight from there to there. So maybe I'll do one more with it, and then we'll skip that step. So I'm not doing a good job of color coding. This is going to become u. This, the negative and the dx is going to become du. So when I substitute, that negative is gone. It's part of the du. I've got something to the 6th, right? Where'd it go? U to the 6th. And then this whole negative and dx becomes du. And then now it's a piece of cake. Whoa. Sorry to be sideways. So raise the power, divide by that power, plus c because it's indefinite, no endpoints. And then substitute the u back in. So the u is 2 minus x, and we're done. Okay? So let's jump to the back side. Let's save b. So, huge important concept. How do we know what to choose for our u? I mentioned that a minute ago, so take a second and talk to your neighbor and fill that in. We probably only have time for one more example because we're at 13 minutes now. So let's do D. Oh, let's do D. Some trig. Y'all need to start following me on YouTube so I can load videos longer than 13 minutes. Okay, so which function is inside of another function? Oh, time to go. Haha, just kidding. U equals tangent theta. So du over d theta in this case, what's the derivative of 1 plus tangent theta? Hopefully you have your derivative rules memorized. And then again, we can jump straight to this if we wanted to. So I'm going to substitute a u in there, something to the 5th, right? And then I'm going to substitute this whole secant squared theta d theta is going to become du. So this is a u. I'm going to have students walking in any second now. You can probably hear people in the hallway. Raise the power, divide by that power, don't forget your plus c, and then substitute the u back in. And that's your answer. I have 30 seconds. Okay, we're going to learn a shortcut for this on Friday, but I want you to practice it with the u, and then we'll learn a shortcut, and we'll talk more about the chain rule. All right, have a good day.